Now finally, we're going to use Excel to do a simulation of more than 10 trials. This time we'll do 100 trials using all Excel formulas. What we're given here is already a finished version. So you could see you have trials 1 through 100. We have the random numbers here and the corresponding random variables here. And the first year demand here. And then here we have the summary statistics. And now on the right hand side of the sheet you see the formulas. These are the formulas for generating values of random variables using the R, that is the numbers from the rand function. Here we have the calculations of the profit functions and the summary statistics. That is how to get them. Now we're going to recreate this by deleting lots of numbers and then doing them over. So I'm going to delete the values from the cells that we are going to work on. I'm going to leave the random numbers alone. Okay, and now you're ready. The first thing is setting up a table for a discrete distribution. A direct labor cost, remember, had a discrete distribution, and here we're given the random numbers to use for generating the 100 values for direct labor cost per unit. So first we need to set up a table that is a random number intervals. Now remember that we start with a 0, and the length of the interval, that is a difference between the upper and the low random numbers, must be the probability corresponding to the cost per unit. So here what we would do is I just add the probability to the lower random number to get the upper random number. Then here the lower random number starts off with the previous upper random number. Now I could copy these down to the bottom of the table. Here I'm going to do something to make sure that I don't lose the border of this table, fill without formatting, and same thing here. Well, actually, you don't have to use formulas. Here you could just enter the values in yourself. They are simple enough to figure out, and we already figured this out when we did it manually before. Now we generate the costs from the random numbers using the table we just created. Now, if we're doing this manually, we would just look up this number and see which interval it falls into. So 0.385, we would say, well, that's somewhere between 0.3 and 0.7, so we must generate 45. But this could get tiring if you have to do 100 of these. So we're going to use a function called VLOOKUP to look these up automatically. When you're learning about a function for the first time, it's always a good idea to use the insert function button to look up how to use it. So we look up, well, we search for VLOOKUP, say go, here's a match, VLOOKUP. So that's the function we want to use, and let's say OK. So it says here, the VLOOKUP function looks for a value in the leftmost column of a table. So we want to look up this number in the leftmost column of this table in here. So here we're going to click on the cell that has 0.385. Now the table array is a table that contains the values we want to look up and values we want to generate. So that would be from starting with the lower random number column and ending with the cost per unit column. Now the column index number, it says, is a column number in the table for which the matching value should be returned. It says the first column of values in the table is column 1. So there are 3 columns in this table, column 1, column 2, column 3, and column 3 contains a cost we want to generate. So here we're going to just enter the value 3. The range lookup is optional. If you're just looking for the closest match to this number in this column, then I don't have to say anything here. So I'm just going to say OK. And you see we get the correct number. Now let's talk about what Excel is actually doing in this process. It goes down the first column of this table looking for this number. So it says 0, no, that's not the match. 0.1, no, that's not. 0.3, no, it's not. 0.7, oh, that is too high. So let's back up one step. So it's going to pick the closest match to the given number that does not exceed the number. So 0.3 is the closest number to 0.385 that is not higher than 0.385. After it ends up here in this row, now it's going to go to column 3 because that's what it says here. So it's column 1, column 2, and column 3, and it's going to output 45. Now let's practice putting it in ourselves without the help of the insert function. So we're going to say VLOOKUP, lookup value, then table. So pick the whole table starting with the lower random number column. Now let's put in the dollar signs here because we're going to copy this down. Then comma, then 3 for the column number. That's it, right? And now we're going to copy it down just by double clicking. There it is. And you can see that it is correctly picking out the right numbers. 0.037, and that's 43. 0.587, that's 45, and so on. Now let's take a look at the parts cost per unit. Remember, this had uniform distribution, so we would be following this formula. So it's smallest value, 80, dollar signs, plus largest value, dollar signs, minus the smallest value, dollar signs, then times the random number. So 9817, and then copy it down. There they are. First year demand has a normal distribution with the mean and demand given here. So it's NORM.INV, as it says here, random number, mean, dollar signs, comma, standard deviation, dollar signs, close the parentheses. That's it. Then copy it down. So you can see that when the random number is close to halfway, 0.5, it gives you a number that's close to the mean. And when the random number is very small, then the first year demand will also be smaller than the mean. Now we have the profit left to do. The profit was 249 minus the cost first. So 249, let's look for it. It's right here. Dollar signs, minus direct labor cost per unit, minus parts cost per unit, close the parentheses, times the first year demand. Okay, then minus the fixed cost of $1 million, but we gotta look for them. There's a $400,000, dollar signs, minus $600,000, dollar signs, so that adds up to subtracting $1 million. Okay, that's it. And then again, copy it down. Here I calculate the averages here just as a check. Now direct labor cost per unit is average is $45. Now does that make sense? Yes, because 45 is the expected cost, which is the theoretical mean. Now the parts cost, the average is about $90, which makes sense because it's 90 is the average from the uniform distribution between 80 and 100. Normal distribution, the mean is 15,000, and the mean from the simulation is 14,000 something. That's close enough to 15,000. And here is your average profit. From our simulation, we generated here 100 profits. With these values, we could do all kinds of statistical analysis to help decide whether to venture into this product. I'll show you some basic statistical results by filling in the summary statistics section right here. The formulas I will use are summarized here on the right. Since we'll be referring to this profit column several times, for convenience, we're going to give this whole column a name. There are several ways to give a cell range a name. Here's one way. So choose the entire column of cells and go over here to the name box and then just type profit and then hit enter. So now I have named it So in the name box, I could see it. If I select that name, it highlights the cells that are named profit. Okay, now let's go down here. First, the sample size, that's just a number of trials. So it's, 100 trials, 100 rows. So we just put that in, 100. Mean profit, as you know, you could just use the average function. So we type average, and then we could just type here profit, okay, to refer to the whole profit column. It's 642.59. For the standard deviation, we would type equal STDEV. If we were using an older Excel, we would just stop here. But in the Excel 2010 or 11, you are supposed to use stdev.s. That's the more current function. And S stands for sample standard deviation. Then we would just say profit, then close the parentheses. So remember, standard deviation gives you an idea of how variable the profits you generated are. Gives you a measure of spread or a risk. So the higher the standard deviation, the higher the uncertainty, so higher the risk. It looks like here the standard deviation is almost as large as the mean profit, which indicates that the risk level is pretty high. And minimum profit, smallest profit that we generated, just type min. And the maximum profit, we use max. Okay, so you could see the minimum profit is negative 541, and the maximum profit is almost 2 million. Okay, now we might ask, what is the probability we will lose money on this? We could estimate this by seeing what percent of the profits we generated were negative. So first we need to count how many values in the profit column were negative. Instead of counting the negative values ourselves, we could use Excel's COUNTIF function. For number of losses, I'm going to use the COUNTIF function to count how many profits are negative. So here you can see there's a range and then there's criteria. A range is a set of data values like profit, and then criteria is a condition you give like the less than 0. Then it'll give you a count of the values that meet that condition. So here I'm going to say profit. Then criteria is, it should be enclosed in double quotes, is less than 0. That's negative. And then hit enter, it gives me 12. So it tells me that the 12 out of the 100 profits were negative. So to get the probability, I just have to divide the 12 by the sample size, number of profits. So this tells me that there's about 12% chance of losing money on this product in the first year. And you could also get other kinds of probabilities. For instance, suppose you're told that in order to launch this product, the management would like to see at least 50% chance of making $500,000. Then we could calculate the probability that the profit would be at least $500,000. So it's probability that the profit will be at least $500,000. So here I would say COUNTIF profit. Okay, then the criteria is greater than or equal to 500,000. Double quotes, greater than or equal to 500,000. And then close the double quotes. That will give me the count, and I need to divide this by 100 to get the probability. So that gives me 0.59. So it says there's 59% chance of making at least $500,000 in the first year. So perhaps we might go into this product. I'd like to show you a couple of other things. The value at risk here and the frequency table. When we want to assess the risk of a new investment or a venture, one of the popular ways to measure the risk is with value at risk. It represents the nearly worst possible outcome. Not the worst, but nearly worst. The value at risk is given commonly at 5%. That basically represents the 5th percentile. Suppose we have a profit distribution like this. And here's the worst possible outcome, that is lowest possible profit. And here is the highest possible profit. the value at risk would be the fifth percentile here. So that would be, if I take 5% here, so that is 5% of all these profits are in this tail, then the profit that corresponds to that 5% probability is the value at risk, or VAR for short. So basically, fifth percentile. So remember, the percentile tells you what percent of the data are lower than the given value. For example, when you take a standardized test like the SAT, if your score is, let's say, 90th percentile, that means 90% of the people got lower score than you did. So you're in the top 10%. So here we're talking about bottom 5%. So to get this, we would have to get the fifth percentile, which in the old Excel, it used to be just called percentile. Now there are two kinds of percentiles, PERCENTILE.EXC and PERCENTILE.INV. EXC means exclusive, INV means inclusive. In our situation, the more accurate measure would be with the percentile exclusive. Basically, percentile inclusive means the lowest value is considered to be at 0th percentile, and the highest value is considered to be at 100th percentile. Exclusive does not include the 0th percentile and the 100th percentile. So using the percentile exclusive. Okay, so we give it a profit, and then the K is a percent. What percent do you want? Here we want 5%, so we could just enter 5%. Or you could enter 0.05, either way it'll work. So it gives us 149,224 negative, so that would be the loss of about $149,000. And usually we give the absolute value of the percentile when we talk about value at risk. So for the value at risk, I would have to take the absolute value of the negative number I have. Okay, and let's turn it into a dollar amount. Let's say dollar here. So here we would write the number here corresponds to negative 149,225, and the value at risk is actually the positive. So it's 149,225, and the mean, of course, according to our simulation, is 640,259. Now, if you had an older Excel that doesn't have the exclusive inclusive options, you would just use this function percentile. So it'll give you the value that is the same as the inclusive. So that number will be a little bit different from the number you get here, but that's okay. Its difference is not that significant. Now, we were talking about COUNTIF function. So you can use a COUNTIF function to count how many profits are in some given range. A systematic way of doing that would be to build a frequency table. So we have a list of intervals for the profit values, and then for each interval count how many numbers are in that interval. That will give you a better picture of how the profit values are distributed. Now, building the frequency table is optional, so you're not responsible for knowing it for assignments or the exam, but it's something good to know. So I'll show you how to build a frequency table for those people who are interested. The steps are summarized in this box. First, what we need to do is decide on the intervals. You could see from here the minimum number was around negative 500,000, and the maximum was close to 2 million. So let's say we have intervals of length 500,000. Maybe that would work. So here are the intervals, lower and upper limits of the intervals. And first upper limit, we're going to say 500,000. So this interval will have all the values less than negative 500,000. Then we have from negative 500,000 to 0. And then we just copy this down to, let's say, 2 million. And here we copy this down. The upper limits of the intervals here are called bins array, as it says here. So we don't really need the lower limits, we just need the upper limits to build a frequency table. So now here we are going to have the frequencies. So what Excel will do is it will count how many values are in each interval, and it will also count how many values are higher than the highest interval, so over 2 million. So it's going to fill in column of this size. And it is an array formula, which means you have to go through a couple of special steps, as it says right here. You highlight a column of cells with one more cell than the bins array, and then you type frequency. Then we indicate we want to count numbers in the profit column, and then we select the upper limits here, then close the parentheses. Now here, instead of hitting enter, we need to hold down Control and Shift and then hit enter in order to fill in the entire range with the frequencies. So we hold down Control Shift and then enter. And this is the same for the Mac. So this tells you counts in these different intervals, and if we want to, we could also build a probability distribution from this by dividing each frequency by the total number of profits.